So, yeah, on to Lagrangian particle tracking and oil spill modeling now. So yeah, again, the resources available on the web. So Lagrangian particles, the big advantage of Lagrangian particles is that you can have any number of particle groups. So say you wanted to put a bunch of particles into your model domain in different areas, you can track each of those groups separately, which will allow you to figure out where water that's released at certain points or particles that are released in different points in your model, where those might end up in your model domain. Yeah, as it says up here, you can release them all at once or set a specific time interval for the release. We can specify a settling rate. That is a really nice feature, actually, especially when you think about the analogy that these particles can have to sediment particles. You assign a settling velocity, and these particles behave in largely the same way that a sediment particle suspended in the water column might. So you guys already went through the process of building a sediment transport model. So you could imagine that maybe if you don't have all of the data, or you're not quite sure if you need to go all the way to a full sediment transport model, using Lagrangian particles might be kind of a step shy of that, but will give you a lot of the same information if you were to assign a settling velocity to those particles. And of course, when the particles settle to the bed, you can set up the model so that as soon as they touch the bed, those particles will deposit and they'll no longer be tracked by the model. So that saves on computational burden, and it's also something that's a little bit more realistic because particles can't be resuspended from the bed. So that's kind of one of the big differences between what you might get in terms of results out of a model where you're looking at the behavior of Lagrangian particles versus a full sediment transport model. We made significant changes to the Lagrangian particle tracking algorithm for version 10. And one of the big changes is that the algorithm is now efficient enough that we can handle and track on the order of 1 million Lagrangian particles and not slow down the model significantly. In the original implementation, the model went through every single Lagrangian particle that could be in the model domain and checked if they were still active or not at every single time step. And so we changed it so that it was only looking at particles that would be active in that day, and then any particles that were active at the end of the previous day. And that's how we were able to make it a little bit more efficient. And then another handy feature is that the final location that the particles are deposited, either at their time of deposit or at the end of the model run, can be exported as a CSV file, brought into other packages, so you can do some kind of post-processing analysis. We're also working on adding some more features that would allow you to make simple heat maps for particle deposition locations. That would allow you to kind of figure out what are the main areas where your particles are depositing. So Lagrangian particles in EFDC model also have the ability to mimic the behavior of oil spills. So we can, we can add density to them. We can add different kinds of, a volume characteristic or biodegradation characteristic. And so each group of particles can have different properties, and so it could simulate different kinds of oil or any kind of substance that might be lighter than water, might be transported by water and wind, and might also be degrading or dispersing into the water column as well. So here you see the parameter setting screen for where you would set up a oil spill model. Again, this is just an option that's available in the Lagrangian particle tracking module. That you can define all of these characteristics of the Lagrangian particles. So now we're going to get into the how the GUI looks. So the main dialog here is the Lagrangian particle tracking main options. In the first box here will give you a summary of the number of drifters. So the drifter number here, you notice this is grayed out. That's because drifters are created in the seeding utility here, which we'll be looking at next. So this is kind of the global controls for the Lagrangian particle tracking module. We can set when the particles are going to be turned on and turned off. We can set the output frequency. We can, here in the next dialog, we're looking at vertical movements. So here the setting says that we can allow full three-dimensional movement of a naturally buoyant particle. So whatever parcel of water that particle is associated with, it will kind of move with that parcel. We can also just simply fix them at the initial seeding depth. We can set either elevation or depth of the particle. And we can also add a random walk component, which will add an element of randomness to the particle behavior. That can be useful for mimicking, maybe a more realistic motion of particles in the system. You have the option of how these random walk components are going to be modeled. So one option is just to use the AH and AV components of the hydrodynamic model and apply them directly to the Lagrangian particles, or you can set your own constant diffusivity values here. And then there's also a wall slippage factor. So by default, particles won't get stuck to the wall. In previous versions of the Lagrangian particle tracking algorithm, particles would end up getting caught up on walls, which wasn't realistic. So the seeding utility, this is where you create a group of Lagrangian particles. So we start out by specifying the number of drifters in each group. We can specify the settling velocity here, and we can create a new group, delete or rename a group. If we want to set up an oil spill model using Lagrangian particles, this is where we would set it up. And of course, all the other options that I mentioned before, fixing deposited particles, whether or not you're going to release them on a single date. So if you set that, then you would just need to go in here and give it the parameters that you would need to create those input files. We also have a lot of control over where the particles are going to be seated horizontally and vertically, and that's what you see in this option here. So if you have this regional control file option set here, then this dialog is going to come up. And this regional control file can be any kind of shape file, P2D file, similar to what you've been using in the other exercises. And that'll just tell the model which spatial area you want to seed those particles in. Those particles can be seeded in that region either randomly or with uniform spacing. And then if you wanted them uniformly spaced, you would just specify the parameters of that uniform spacing here. And so the number of particles that you're going to create in that group, you would enter in that value here. And then once all of this is set up, not just the horizontal, but also vertical options, then you would click Create Particles. And then that group would be created in the input file for the Lagrangian particles. Now, this is something a little bit that you definitely need to be aware of, is that once you've created this particle group, say I wanted to change the seeding depth of these particles. Now, it's going to look like you can just modify that value and then hit OK, but actually you need to recreate that particle group if you wanted to change the horizontal placement or vertical placement of those particles in the initial conditions. That's because when you hit Create Particles, it's writing all that data out to the file. I think we should be adding in the near future an ability to kind of update a particle group. But for now, if you wanted to change any of those properties of the specific particle, you'll need to recreate the group. So yeah, here again are the oil parameters, density, volume for the group of oil, biodegradation rate. These are all just options that you can specify. And yeah, so that is pretty much the extent of the Lagrangian particle tracking lecture. So you can continue on with if you're still working on the wind wave modeling section, or you can move on to Lagrangian particles.